Okay, so the next important variation that occurs physiologically in the heart is the contractility increase. And this can be seen in any positive inotropic state. Um, and what is an inotropic? Inotropic just means force of contraction. Positive means greater. And so that can be done by drugs, noradrenaline, adrenaline. Those are similar. Those are the same as saying norepinephrine and epinephrine, and that can be observed when you're having, for example, you activate the SNS, the sympathetic nervous system, which usually, if you can think about exercise, you're going to be seeing this effect. Okay, so what happens if you increase contractility? Well, the force of a contraction will be greater. That's the first thing. And that is represented by point D towards E, right? Because you're going to be having greater contraction, meaning you're going to be able to expel more or eject more blood than what you normally are doing. What does that mean if you're having more contraction? Not more contraction, the contraction is greater. Once the contraction is greater, that means a new maximal systolic pressure will be obtained. As you can see here, from E to E, there's a change. Okay, that's the first thing. The second thing is that because there is going to be a change from the systolic pressure from E to E prime, to E, you see that will remove more blood from the heart. How can you see that here in the graph? Well, point E prime is right around here, right? That's the volume at which it is. If you increase the contractility, it will shift all the way to here. So if we go all the way to the bottom, there's a change, meaning you're going to have less volume at the end. Okay, I hope that makes sense. And so now that you have this done here, you see that the relaxation ejection phase, will end at a new stage, meaning the aortic valve will close over here, right, rather than down here. Okay, so again, this represents there's going to be less volume at the end. So what's this point again? This point represents the end systolic volume, correct? Because it's at the end of the ventricular contraction. How much volume has been left in the left ventricle at the end of the ventricular contraction? So we see that it has been decreased, right? Can that be observed here? Where from A prime has been shifted towards the left, and that is less volume. Okay. What does a decrease in end systolic volume mean? Well, again, always look at the formula. Stroke volume equals to the difference between end systolic volume, that's a D, and diastolic volume minus end systolic volume. And so if you see an decrease in end systolic volume, it will represent as an increase in systolic volume, because the difference is going to be greater. All right, and that's all it is. So you're going to see an increase in stroke volume as well as force of contraction when there's an increase in contractility.